Hello, my name is Miranda and this is Lab 2 over the magnetic field of a bar magnet. The purpose of this lab is to measure the distance dependence of the magnetic field due to a small bar magnet in comparison to the results predicted using the Biot-Savart law. And I found that the magnitude of the net magnetic field increases as the distance decreases, and the distance dependence was to be 1 over r to the 2.665 power. The fundamental principles of this lab include Biot-Savart law, which states that the magnetic field due to a tiny current element at any point is proportional to the length of the current element, the current, the sine of the angle between the current direction and the line joining the current element and the point, and inversely proportional to the square of the distance of that point. I used a dedicated magnetometer app in my phone to measure the magnetic field due to a permanent dipole magnet. The system is the bar magnet, and the surrounding is everything else, including my smartphone, myself, and the Earth. And the initial condition is that the magnet is placed on an east-west axis. This slide shows the data I got for this experiment. For the first part of the experiment, I measured distance at different magnitudes of B bar, and the data is on the top, where I took advantage of the equation magnitude of the B bar equals K times r to the nth power, where K is the combination of parameters and constants. And by measuring the value of B bar, I was able to determine the numerical value of n. And the data I got for the off-axis and perp axis is listed down below for the part 2 of the lab. Using the data I have from the last slide, I created a computational model which is shown on this slide. My code can basically be broken down into 3 parts. The first part is about constants and functions, and then I have all the values calculating the on-axis and perp axis, and then the last part, which is from line 60 to 65, is when there is a 45-degree error. This slide shows the graphical illustration and the numerical result I have after I run my code. To answer the first what-if question, the results would have been varied greatly if I did not compensate for the magnetic north when I was setting up the experiment at the start, because there would have been a much stronger effect from the Earth magnet pole that I did not compensate for, and that would change up my numerical answers and affect the accuracy of the experiment. And to answer the second what-if question, I would expect the results to increase twice if I used 2 identical magnets stuck together end to end instead of a single magnet, because there would be a different dipole separations and an increase in the strength of the magnet. The calculated result of 1 over r to the 2.665 power from part 1 of the experiment indicates the overall accuracy of this experiment, since it is pretty close to the expected value of 1 over r to the third square. And by comparing the result from the manual calculation from the part 2 of the experiment and the computational model using the data I have, I found out that the Earth magnetic field has a great impact on the dipole magnetic field, and some sources of error include me not perfectly aligning the sensor to make up for the magnetic north from the Earth, and me not correctly finding the location of the magnetometer in my phone, since the way to find it might not be precise enough.